Hello guys, so today we are going to solve our next lead code problem that is going to be the top k frequent elements. And let's start with the problem description. So we are given an array of integers where we have to find the most frequent uh, elements from that array, right? For example, if we have, let me just change the color of this. For example, if we have this array here, for example, and we want to find the k most frequent of these this array. So let's just count it out. So if we count it out, we can actually see we have like one occurring three times and two occurring two times. So we can actually just return one and two that are the most frequent occurring elements, right? In the second element, second array we have just only one. Then we're going to just going to return one, right? So we have two solutions to resolve this problem. One is to use the max heapification method to resolve this problem, and the other is bucket sort to resolve this problem. So if you guys don't know about what the heapification solution for this, you can just visit like Isugi's for to understand the data structure of it. In the max heap data structure, what we usually encounter is we have a priority queue that sorts the elements as it like appends the elements into its queue, and what we have in result is a sorted data structure where the max element would be sorted in the top, and if you want to go into the further max, you can just go iterate like the uh, the right side of this data structure as well to get the most like second most max number of this. So this is how things are going to go in this data structure. But the thing about heap data structure, the time complexity regarding this is going to be uh, let me just write k k log of n times. Why is this the case? Let me just first, break the data structure down further. Because in the k times, what we're going to store, what we're going to do is either we are going to obviously sort the elements, right? We are going to sort these elements on each iteration. So k is going to be the number of like insertions that we're going to make. And log of n times is going to be the number of like iterations that we're going to make to like sort those elements out. So this is how this data structure is going to be. So that is why we have a time complexity of k log of n times. And the space complexity is obviously going to be of n times the number of elements that we have. It's like if we're going to store from another array, uh, that's going to be of n as well. So where the data structure that you have already. If you already have uh, the priority, for example, the queue data structure, and you're just going to resort the whole thing, then you don't need a space complexity. But if you have something of an array or something, and you need to insert into some other array, then you need like a time complexity of n because obviously you're just going to resort those things out and start appending those elements into another array. Okay, so hopefully you got the Max Heapify data structure and how to use it. I would definitely attach this link if you want to just go through this data structure. But we have another mechanism that can actually sort this out in a more convenient manner, and that is actually ON in linear time, I would say, and that is the bucket sort mechanism, and it's going to be a different kind of a mechanism as compared to the usual bucket sort. So if you go to the bucket sort on how bucket sort actually works, let me just define it here. So how bucket sort actually works is like this. We have a bucket here, and what we usually do is to like This is actually going to be about the typical bucket sort mechanism that we see. We have this bucket here, and the bucket, what we do is we start from zero to a predefined number of like elements. We have a very limited bucket, I would say. That's how bucket sort usually works. Bucket sort has two conditions. Is to have a limited amount of size of the bucket, that the size is predefined, and also Uh, elements has to be from, I think so, from zero, from the decimals to predefined decimals, I would say. So definitely this would be if I remove these elements again. So this would be from 0.1 to 0.01. Let me just erase it again. 0.01 to 0.1. So 0.02, 0.03, 0.0. This is how bucket sort actually works. Like, let me just write down our typical bucket sort. Two conditions. One is to have. So this is how things are going to be. We are going to like store the number of currencies here as keys, and we are going to like store the elements, like the elements that have occurred for the elements in the list we have are going to be stored in here. So why we have like done this sort of a bucket sort mechanism? The answer is very much simple. So let me just clarify the answer a little bit on how we are doing, why we are doing this. So for example, let's say we have this array, right? Let me just copy this down. Uh, for example, let's have this array here, the typical array that we have, and let's see we can actually like debug this one by one, step by step. So first, what we're going to do is to like have the counts of this, like how many times these elements occurring. So let me just draw a hash map here. So we have this here. Okay. So we have one occurring three times, two occurring two times, three occurring one time, right? We have this data here. First step is going to be this. First, count these elements down and how many times these elements are occurring, right? Then what we're going to do is to have this the counts here as keys. For example, three on the most frequently occurred. For example, let's say we have three times, right? The size of this is going to be one, two, and three. This is going to be the actual size because you need to consider that the bucket sort is already bounded. It has to have predefined size. So if you go with the typical approach of having all of this considered, that's not going to be working because we need to have predefined size, and that is how that is why we have this as the number of occurrences as the predefined size. So it's very much limited because we already know how many times these elements have occurred. So we have the predefined size, right? We have the predefined size. The maximum it's going to be like three because we have three times three distinct elements that have occurred. And what we're going to do now, we have a predefined size now, three, is to like write these occurrences. Like uh, for example, let's say plus one because we need to consider zero as well. If the elements have not occurred. Zero, one, two, and three. So size plus one. This is how these elements are going to be defined in a bucket sort now. First, we need to like get the count of it in a hash map. Then what we need to do is to convert this into a bucket sort where we store the frequencies. And in those frequencies, we're going to store the list. So what we're going to do is we're going to get the elements there, the distinct elements, on how many times, on how many elements that we want, right? K is equal to most frequently occurred elements. So for example, what we're going to do, we're going to have one here. Sorry, we're going to have, let me just write it down. We're going to have in, we have like, for example, one occurs three times, right? For example, one would be here and two would be here and three would be here, right? And this would be in list, obviously, because we can have other elements as well. For example, if I pen, for example, let's say if I add another three here, right? For example, if I modify it, if I add another three, we have two threes, right? So this is going to be transition towards this. For example, we're going to erase this and we're going to have to add another member here. That is going to be three, three. So I hope that you actually get the clarification of this problem. And when we are asked to return the k most frequent values, right? So we're going to iterate from here. We're going to iterate from the end of this array, from here, and now we're going to move reverse backwards. We're going to reverse because we know the most frequently occurred elements are going to be starting from here because this key represents the number of occurrences. The higher the number of occurrences, the way that we're going to start from here. So we're going to start from this, and we're going to have a resultant array. We're going to have result empty array here. And in this empty array, we're going to start appending these elements from the most frequent elements. So for example, we're going to start append one. For example, let's say we are given to return the k most frequent, right? K is equal to 2. So we have 2, right? We want to return two elements that occur the most frequent. So we're going to start from here. We're going to append 1 here. Then we're going to append 2. And then we check if those, if the size, like we have two elements and we have the limit as 2, we're just going to return 1 and 2, right? This is how the mechanism is going to work. So let's just dive into the code. First, what we're going to do is the typical same thing as explained. We're going to get a hash map of it, and then what we're going to do is to define the frequency, and that is going to be the I in range length of nums plus one, because you need to consider thing that I showed you earlier. We need to consider zero as well as for this. For now, what we need to do is to first get the hash map of it, hash map count. Let's calculate the frequencies. Let's calculate the counts. Count dot get n 0. We are using this because if we don't find any element in the count, then we just return 0 and just have this as incremented one as a starting point. And then the we need to calculate the frequency now, n and c in count dot items. Now we're going to do this to have our bucket buckets being like calculated now. Frequency, we have the count here in the index, and then we have the elements being appended to the list here that we have defined here. Now what we're going to do is to like iterate in the reverse mechanism as I told you earlier for I in range length and nums, sorry, frequency, and minus 1, I guess, and also 0 to go to the end of the list, and we have a decrementer minus 1 because we're going to decrement from minus 1 to this. And then what we're going to do is to iterate the list now. frequency I. And now what we're going to do is to append, we are going to also have a resultant array here as well. In the resultant array, what we're going to do is to append the elements. And now we need to check if the length compares to k. And if we have the length compared to the k items that we want, we can just simply return the result. That's how things are going to go. Let me just go through it one more time to check if everything is good, everything is intact. Okay, I think so we are good to go. Yeah, let me just fix the syntax as well. Hmm. So yeah, so everything is looking good so far. Let me just submit it out so we can see. So hopefully you guys can understand the whole crux of the problem. Uh, and hopefully if you do like the video, do subscribe to my channel and like the video. And I also would definitely be looking forward to your thoughts as well. Do share your thoughts in the comment section below. So see you guys in the next video. Take care, guys. Bye.